Yeah, good morning, students. So today's topic for discussion is basic operational units of a computer. So now I would like to share my screen. So basic operational concepts. So today's lecture objectives are so you can gain the knowledge on basic operational concepts of a computer. So generally, the activity in a computer is managed by instructions. So whenever you want to perform any activity within a computer, so you will perform through the instructions. To perform any task in a computer, we are going to write a set of instructions which we are calling it as a program, and that program is going to be stored in the main memory of a computer. So the individual instructions which are stored within a program, they are brought from the main memory into the processor. So the processor will execute the specified operations. So generally, this is one important term, program. So we have to write the set of instructions we have to write to solve a particular task. And this program is going to be stored in the main memory. Whenever we want to execute this program is brought into the or loaded into the main memory, and the processor will fetch instruction by instruction from the memory, and it will be executed by the processor. So that is very important step how we are executing the program. And whenever we require some data as input for execution of a particular instruction, so the data is also be stored within the memory. So for example, consider a instruction, so which we are calling it as load R2 comma LOC. So here this is the operation what we want to perform. We are specifying this is an operation. Load is an operation, and here this R2 is nothing but it is a register, CPU register, and this is a LOC is nothing but it is a variable which is holding some value, and it is stored in the memory. So what we are doing with this instruction, what the processor is going to do that, so it will load the value stored in the LOC into the register R2. So this instruction reads the contents of a memory location, okay, which is symbolically named with LOC, and it will load that value into the processor register R2. So this instruction is fetched from the memory into the processor. The operation to be performed is determined by the control unit. So in this particular instruction, what operation we have to perform? For example, here in this instruction, we are performing the load operation. So that is determined by the control unit. So the operand specified in this instruction is LOC, and this is fetched from the memory into the processor. So the operand is stored into the register R2. So after operands have been loaded from memory into processor registers, now the arithmetic or logic operations can be performed on those operands. For example, consider another instruction. Here add is the operation, and this is an operation, and these are the operands we are specifying within this instruction. So what this instruction is going to do, in the processor registers. So all are these three operands which we have specified here in this instruction, R2, R3, R4, all these are the processor registers. So what it does is that they can be transferred to the memory using the instructions such as store. So that means what here it is doing, this instruction, what it does is that, so the register R4 is stored with the contents of register R2 plus the contents of register R3. So R2 and R3 contents are added and the result will be stored in the R4. Now the result which we have in the processor register R4, we can store into a memory location by making use of this store instruction. So we can write store R4 comma LOC. That means the contents of R4 register will be now loaded or stored within this memory location pointed by this or symbolically named by this LOC. So here we are using two important instructions, load and store. These are the two important instructions which are used for transferring the data between memory and the processor. So what we are doing here, load and store are the two important instructions, mention instructions, which are used for transferring of the data between the main memory and the processor. So how it will be transferred? So the control unit will send the signal to the processor to fetch the data from the main memory into the processor register, does the operation. Now the result we want to store again into the register. So again the control unit will send the signal to transfer this data from the register R4 to a memory location named with LOC. So like this the control instructions, load and store, are the two important instructions which are used for transferring of the data between the memory and the processor. So if you see how this connection between the processor and the main memory will be there, so this is called it as an interface between a main memory and the processor. So generally here this processor will have control unit and arithmetic logic unit, so which we already discussed about these two components in a self-learning topic, functional units of a computer. Arithmetic logic unit is used for performing arithmetic and logic operations, whereas the control unit is used for controlling all these components which are available within the processor and coordinate the operations which we can perform between these components. Now the processor will have a general purpose registers like R0, R1 and so on are n minus 1. So there are n number of general purpose registers are there in every processor. Along with this n number of general purpose registers, we have a special purpose register which we are calling it as PC, okay, program counter, and IR which we are calling it as instruction register. So these are the different types of components which are there in the processor, and this is the main memory unit. So this main memory unit and this processor are get connected with an interface which we are calling it as a processor memory interface. This is a processor memory interface we can call it as. So using this interface, the communication between this main memory unit and the processor will be performed through processor memory interface. Now at this point of time, now one question for you students. So what contents are going to be stored in program counter register and IR register? Okay. So the registers which we have seen here is one important register which we have in the processor is instruction register. So the purpose of this instruction register is to hold the instruction that is currently being executed. So what is the instruction currently executing by the processor? That instruction address will be stored in the instruction register. Please try to understand the purpose of this instruction register. So it will store the address of currently executing instruction. Then its output is available to the control unit which generates the timing signals that controls the various processing elements involved in executing of the instruction. So we will see that how the instruction execution cycle will be there in the coming topics. We will discuss that how the instruction execution cycle will be there. So the another second important register which we are calling it as a program counter register. So it is another specialized register which we have in the processor. So it will contains the memory address of the next instructions to be fetched and executed from the memory by the processor. Okay. So instruction register will hold the current instruction which is executing by the processor. Address of that current instruction is stored in the instruction register, and PC program counter register will store the next instruction which is to be fetched from the memory by the processor to execute. So these are the two important special registers that we have along with some general purpose registers in the processor. Program counter points to the instruction to be executed next. So during the execution of an instruction, the contents of the PC register are updated to corresponds to the address of the next instruction to be executed. As earlier we have seen that a program is nothing but set of instructions. So once it is executing the instruction, for example, if you take this is these are the 5 instructions in the program. So now if the processor is executing this first instruction, now the address of this first instruction is stored in the instruction register. The next instruction which is to be executed, that will be stored in the PC. So it is storing the address of the second instruction which is to be executed next. So once the first instruction execution is completed, now the second instruction will be fetched. So the address of the second instruction is going to be stored in the IR register, instruction register. Now after executing the second instruction, what is the address of the next instruction? Third. So that is stored in the PC. So like this here, these two registers, instruction register and the program counter register, these are the two special purpose registers which are used by the processor to execute the instructions one after another in a program. So in addition to these two special purpose registers, so every processor will have some general purpose registers which we are calling it as R0 to Rn minus 1, there are n number of general purpose registers are there in any processor. So these registers, general purpose registers, will serve for a variety of functions, so which are used for holding of the operands that are to be loaded from the memory for processing. Just in the previous we have seen that when we are writing an instruction for add r3 comma r1 comma r2, so where these r1 r2 r3 are the general purpose registers which we have used here. Fine. So the processor and memory interface, if you see that, so it is a interface, a processor and memory interface, which is a circuit, IC circuit, and the purpose of this IC circuit is to manage the transfer of data between the main memory and the processor. So it is a electronic circuit which manages the transfer of the data between the main memory and the processor. So generally when we are reading the data or when we are storing the data, that is the read and write operations, when we want to do that, that is called it as, especially we have seen that load and store operations, load and store instructions we have seen. So generally when we are performing this read or write, load or store operations, so we will perform in terms of words. So a word is nothing but group of bits. We are calling it as a word. Generally, 16 bits we will take one word, or 32 bits we will take one word, or 64 bits we will take one word. Like that, based on the processor type, we will take the number of bits collectively as one word. So read or write operations when we are performing in the memory, it will be always done in terms of words only. So that is what read and write operation in terms of words, we will do that. Now the execution, if you see that a program must be in the main memory whenever we want to execute. So generally it is transferred from the secondary storage unit through the input unit into the main memory. So the programs which are stored, they are stored for future purpose in the secondary storage, and that particular programs will be brought into this main memory. So once they are loaded into the main memory, now it is ready for execution. So when we want to execute that particular program, now the program counter register is set to the first instruction in the program, and the contents of the PC are transferred to the memory along with the read control signal, so that it will read the first instruction from the main memory into the processor. So when the addressed word, okay, so that is the first instruction here, we are saying that has been fetched from the memory, it is loaded into the register, which is called it as instruction register. So at this point the instruction is ready to be interpreted and executed. So instructions such as load and store and add, just now we have seen these three instructions we have seen, which are used for performing the data transfer and arithmetic operations. Add is for arithmetic operation, load and store is for data transfer. So if an operand that resides in the memory is required for an instruction, so it is fetched by sending its address to the memory and initiating a read operation, so that it will fetch that operand value from the memory. So when the operand has been fetched from the memory, so it is transferred to a processor register. So after operands have been fetched in this way, the arithmetic and logic unit will perform the required operations, arithmetic and logic operations. And then the result is again we can send to a processor register, and if we want to store that result into the main memory, so we can initiate a store instruction, so which will be used for transferring of the data from the processor register to the main memory unit. So that is initiated, store will initiate the write operation, load will initiate the read operation. Fine. So at some point during the execution of each instruction, so the contents of the PC are incremented, so that PC program counter will always point to the next instruction to be executed. Thus, as soon as the execution of the current instruction is completed, the processor is ready to fetch a new instruction into the main memory. So in addition to transferring data between the memory and the processor, The computer accepts the data from the input devices and send the data to the output devices as a result. So some machine instructions are required for transferring of the data from input device to the output devices. So that is done through IO transfer. So normal execution of a program. So here what we are doing here is that, so we are monitoring the devices in a computer controlled process, and we will detect that based on that situation we can initiate this device. So in order to respond immediately, so the execution of the current. So now coming to this last important point here is that, so once the instruction is executed, okay, so you can include that what are the contents of the PC and what is the contents of the general purpose registers, and what are the some control information just like read, write, load, store, such type of information we have to pass that. So whenever a high priority devices requires the service of the processor, so your currently executed program will be temporarily suspended, so that we are providing the service to that highest priority devices by making use of this interrupt service routine. So where we are currently interrupting the executing process, and then we are providing the service to the highest priority device. So this is what we are coming here. And the lecture level practice problem for today's classroom discussion topic is that, so with a neat diagram illustrate the operation and connectivity between the processor and the main memory. The outcomes of today's session is that, so you will able to understand the basic operational concepts of a computer, and how the computer is having different types of components, and what are the important registers which we have in the processor, and how the processor and main memory is get connected through an interface, processor memory interface. Okay, so thank you for patient listening. So thank you one and all.